everybody, I just wanted to spend a little bit of time talking about what molecular geometry is and kind of setting the groundwork for explaining how to determine some molecular geometry. It turns out that when we represent elements bonded together in a Lewis dot structure, that we can actually give those molecules a three-dimensional shape. Okay, and that three-dimensional shape that a molecule has is called its molecular geometry. Okay, so it's important for us to go over first some vocabulary, and so you can see here the three big things that we're talking about. Okay, molecular geometry being the big one, which is the arrangement of the atoms in a molecule, and we represent those atoms using Lewis dot structures. And the other two things that we're going to spend a lot of time in this video talking about are electron domains, which is a place around the atom that has electrons, and then a bonding domain, which is a special type of electron domain that has at least one bond in it. Okay, so let's talk about this. And let's do this through example. So here we have this compound NH3, and you can see in the NH3 that there's a certain arrangement of the hydrogens around this central atom of the nitrogen. So when we're counting electron and bonding domains, we want to first look at the central atom. So we're going to look right here at the central atom, and then we are going to say, okay, how many places are there with electrons around it? Okay, so, well, keep in mind that the bonds have two electrons in them. So each of these lines is an electron domain. Plus there's this electron domain up here. So how many electron domains are there? There are 4 electron domains. Now, how many of them are bonding domains? Well, that's a fairly straightforward question, because how many bonds are there? There's 1, 2, 3. So for this would be 3 bonding domains. We go on to the next structure. Okay, so here we have water, H2O. And so H2O has some free electrons here, and then has a couple of bonds. So we want to count how many electron domains, how many EDs are there? Well, again, the bonds count as, this bond counts as 1, this bond counts as 1, and then there's a pair of electrons here, and then another pair of electrons here. So this also has 4 electron domains. How many bonding domains? Well, it has a bonding domain here and a bonding domain here. There's 2 bonds around it, so there's 2 bonding domains. Okay, so now this is methane. This is natural gas. So notice this has a interesting arrangement. It looks like it's just kind of a flat, kind of a square or diamond if we were to connect this. Okay, but the geometry is in 3 dimensions. So that's going to be the next thing that we're going to worry about in the next lesson. But how many electron and bonding domains are there? Well, each of these bonds counts as an electron domain. So there's 4 electron domains, and then each of them is a bonding domain. There's nothing there other than just bonding domains. So this is 4 electron domains, and all of them are bonding domains. We could talk about ions. They have bonds and they have a structure. So let's look at this. And so there is one thing to worry about here. You'll notice that there is a double bond here. Okay, now a double bond counts as only 1 bonding domain and 1 electron domain. So this is all one big space where there's electrons and bonds. Okay, so this has 1 bonding domain, or 1 electron domain, 2 electron domains, 3 electron domains. We're only looking at the central atom. Okay, so this has 3 electron domains. And then the question is, what how many of those electron domains, because of how many of those, the question is how many of those electron domains are bonding domains, because a bonding domain is a special type of electron domain. So you can't have any more bonding domains than you have electron domains. So each of those electron domains have bonds in it. So there are 3 bonding domains. Okay. We can have expanded valences. Okay. And again, it's just a matter of counting. Okay. It's going to be very similar to what we did with Lewis dot structures. So you can do this, and you can see that there's 1, 2, 3, 4, 5, 6 places around the central atom. 6 places around the central atom that has electrons. Okay. And how many of them are bonding? Well, all of them are bonding. There's not a single place around that central atom that isn't bonding. So that's 6 electron domains and 6 bonding domains. Okay. So now the next one. Here we have a central atom, again in carbon, that has 2 sets of double bonds. So we're going to do the same thing here. That's 1 bonding domain. That's 2 electron domains, 2 places where there's electrons. The double bond is just 1 electron domain. Okay. If you have a multiple bond, it still counts as just 1 electron domain. So of those 2 electron domains, how many of them are bonding domains? Both of them. Okay. Okay, another example. So now here we have an expanded valence. This is sulfur again. And we'll notice here that this has a free pair of electrons. So that means the number of electron domains and bonding domains is going to be different. But there's 1, 2, 3, 4, 5 electron domains. Okay, so that's 5 electron domains. And then how many of them are bonding domains? Well, 1, 2, 3, 4 of them are bonding domains. Okay. And then the last structure we have is this one. And I put this one on here because this is a structure that looks so funny. But regardless of whether you kind of know whether the structure is right or if it looks funny or whatever, you still should be able to determine how many electron and bonding domains there are. So let's count these out very carefully. And remember, if it's a multiple bond, the multiple bond still only counts as one electron domain. So there's 1, there's 2, there's 3, and then this guy in the middle is the 4th. And we're only looking at the central atom. So there's 4 electron domains, and then how many of them are bonding domains? How many of those things that we circled have bonds in them? And then that's 3. So counting electron and bonding domains is a fairly straightforward process, but don't get tripped up when you see those double bonds. Okay, have a great day, everybody.